Welcome to today's video. Today we're going to talk about writing proofs on both angles and segments. We're going to show that mastery in class by scoring at least a 70% on the exit ticket. If we look at our first proof, we're always going to have the given and we're always going to have the proof, and in this case they gave us a nice picture. So our given says angle FED and angle DEW are complementary. We want to prove that FEW is a right angle. Now, when you do proofs, keep in mind, you're going to have your statements and your reasons. Your reasons are why you're doing what you're doing. And as you go through, you need to make sure you're defining every little piece. Even though you know what it means, think of these proofs as if you're teaching it to somebody who's never taken geometry before and never heard of these words and don't know what their definition is. So we have to do every single step. Now, if I look at statement 1, angle FED and angle DEW are complementary. We always want to start with our givens. So reason number 1 is given. It has to be given to us. We have to know what problem we are solving. Now, step number 2 says the measure of angle FED and the measure of angle DEW equal 90. In this case, I know we've gone over in class that complementary means you add them to 90, but we need to explain that to people who have never seen this before. So we're now taking what we said in statement 1 and taking that complementary and telling them what it means. So for number 2, it is your definition of complementary. You need to tell people that, hey, because they are complementary, you add them up and set them equal to 90. Step 3 says angle FED plus angle DEW equals measure of angle FEW. Well, if I look at my picture at the top, I have FED and I add DEW. They are saying it equals the whole part. Now, again, I know we've gone over angles in class, and you know that each section added together equals the total angle. But we're explaining this to someone who's never done this. So this is going to be angle addition. You are taking each part and adding it together to get the total angle. And FEW just is the total angle. Now, if you notice in steps 2 and step 3, both of them have the same beginning part. Since these two parts are the same, we can set the next two parts, which is my 90 and angle FEW, equal to each other. Your reasoning is your transitive property. We can call this A is equal to B and B is equal to C. Well, the B's cancel each other out and you're left with A is equal to C. Now, going from step 4 to step 5, the big thing here is we know that a right angle is 90 degrees. But again, we're explaining this to somebody who has no idea. So now that we know angle FEW equals 90, now we can say angle FEW is a right angle. And the reason is because it's the definition of a right angle. And our definition just is that it equals 90 degrees. So because we said angle FEW equals 90, now we can say it is a true right angle. If we look at our second problem, we have QS is given to us as 42, and there is an S in that picture. We want to prove X is equal to 13. Now, before I even look at the proof and start writing the proof, I want to look at the problem and know how to solve it. Well, if I know all of QS is equal to 42, using segment addition, I know the first part plus the second part equals 42. So now we're going to go through the proof to write that. You know to look at a problem and do that. Now we need to explain what we're doing. Step 1, QS equals 42. Automatically, that is our given. We have to be given a problem to solve. Now, for the second one, QR plus RS equals QS. If I look at my problem, QR is my first endpoint to the middle, and then RS is the middle to my second endpoint, where QS is the whole thing. So, in this case, this is just segment addition. You need to tell people that you need to take both parts of the segment and add them together to get the full length of the segment. But we're not starting with numbers. They need to understand that there's letters to a segment. It is segment QR plus segment RS. Now, if I look going from line 2 to line 3, QR in my problem is x plus 3. RS in my problem is 2x. And QS based on the given is 42. So all we're doing is we're substituting values in based on what they give us in the problem. But now we have to fill those values in. From here, it just becomes an algebraic proof. To get from line 3 to line 4, I take x and 2x and add them together to get 3x. So step 4 is your combining like terms. If I were solving this algebraically, I now know I need to subtract 3 from both sides. Well, if I subtract 3 from both sides, that's my subtraction property. Last but not least, 3x equals 39. 3 and x are being multiplied, so the opposite is I'm going to divide by 3 on both sides. So line 6 is your division property. Proofs are not super challenging, they're just super tedious. You need to make sure that you explain every piece of detail as if you were explaining it to somebody who's never heard geometry terms before. When we talk in class, I know what you mean when you say midpoint or segment addition or distance. However, when you're talking to somebody who's never taken geometry, they don't know those terms. So you need to make sure you define every piece of information. Please bring your notes and any questions you have to class tomorrow. I look forward to seeing you then.